This is Module 2, Unit 2 of the Virtual Electric Vehicle Deployment for Southeast Asia course. My name is Kaylin Bope, and I'm a Transportation Project Leader at the National Renewable Energy Laboratory, working specifically in the Center for Integrated Mobility Science. I have a background in designing and managing financial incentives for alternative fuel vehicles and infrastructure. I currently specialize in alternative fuel vehicle and fueling infrastructure deployment. And at NREL, I provide technical assistance to the United States Department of Energy's Clean Cities program, conduct analysis of United States vehicle registration data, and provide technical support to the electric vehicle charging business model and technical standards work in the LAO PDR. I will be talking about the different aspects of electric vehicle charging, including equipment, charging locations, and deployment. For equipment, I will cover the purpose of electric vehicle charging stations, different levels of charging, types of charging technologies, and types of grid connection and other considerations. From there, I'll review important factors affecting charging locations, including those for home charging, public charging, and fleet charging. Lastly, I'll cover factors affecting the deployment of electric vehicle chargers, including cost variables, a timeline of expenses, ownership models, business models, and coordination with the electric utility. Let's start with the first section of the agenda, electric vehicle charging equipment. What is the purpose of charging stations? Charging stations serve several important roles for electric vehicles, some of these more obvious than others. Of course, a charging station serves as a connection to the electrical grid, and in doing so, is able to refuel an electric vehicle similar to the purpose that a gas station is used for gas or petrol vehicles. However, beyond that basic function, when they are properly installed and comply with electrical codes, these stations prevent circuits from overloading or provide overcurrent protection. In the case of direct current or DC fast chargers, the charging station actually converts the alternating current or AC power of the grid into DC power that can be accepted by the electric vehicle. In level 2 charging, this function happens inside the vehicle, but in DC fast charging, this happens before it reaches the vehicle inside the charger itself. Chargers also ensure a safe connection with the vehicle before electricity starts to flow. This is an important safety feature, both for the person using the charging station, but also for the vehicle and the grid. A properly functioning and installed charging station prevents damage to the vehicle's battery. Charging stations also serve as a point of sale by allowing customers to pay for their fuel via a credit card, mobile app, or radio frequency identification card. Lastly, many, though not all, charging stations have the ability to collect data. This might be as simple as the amount of electricity dispensed or the number of times it was used in a given time period, typically a month. But depending on the type of charging station, they can also collect important data like the type of vehicles charging, for example, how many Teslas or how many Nissans, along with how many unique or repeat users and the length of time spent charging. Think of this data as any business owner might, in that it can be used to help understand how the product is used, when it is used, and by who. By knowing these things, you can interpret trends in the demand for charging in order to deploy hopefully more charging stations and therefore encourage a more robust electric vehicle market. There are two main types of electric vehicle chargers, level 2 chargers and DC fast chargers. I want to point out some key differences between these two. Let's first start with the level 2 chargers. Level 2 chargers can vary in their power outputs. Many of these operate around 7 kilowatts per hour. That being said, the level 2 standard can accommodate a power output as high as 19 kilowatts per hour. Currently, not all electric vehicle batteries are capable of accepting that higher power rating on a level 2 connection, but the standard does go higher than 7 kilowatts. Depending on the size of the car's battery and that kilowatt rating, a level 2 charger can take about 48 hours to fully charge a vehicle from a depleted state. While this is a bit longer to charge, this type of station is more affordable to install and operate. Because of this, it's also generally cheaper for the customer to use as well. For these reasons, level 2 chargers are the most common charging stations available. The range of prices provided on this slide are based on a survey of equipment and installation costs conducted in the United States. So these prices may or may not accurately portray costs in other countries or regions. Next are DC fast chargers. These also have a variable power rating from 25 to 350 kilowatts. The most common is 50 kilowatts, and this is 50 kilowatts is the maximum level that most electric vehicles on the road today can currently accept. This technology is quickly changing though, and we are seeing more electric vehicle models coming out that are able to charge at higher levels, such as 150 or even 350 kilowatts. Despite the vast range in power levels, DC chargers are always faster than level 2 chargers and generally take less than 1 hour to fully charge a battery from a depleted state. Of the two options, this is the most expensive option to install and operate. Because of this, it is also generally more expensive for the customer to use. Again, a quick note, the range of prices provided on this slide are based on survey of equipment and installation costs in the US, so they may not accurately portray costs in other countries or regions. Though they're certainly more expensive than level 2 chargers, they are also less common, but they're very popular with electric vehicle drivers. On this slide, I wanted to briefly acknowledge that there are also other technologies that can provide power to electric vehicles besides just the level 2 and DC fast chargers discussed in the previous slide. These all have benefits and drawbacks, which are listed here. And some of them are better suited for very specific electric vehicle applications, such as transit buses. Starting with the top row, battery swapping is a technology and idea that has been around for quite a while now. And the appeal with this is the ability for a driver to have a freshly charged battery in their vehicle in less than 3 minutes, which is comparable to what it takes to refuel a gas vehicle. The downsides are very much logistical, and not all electric vehicle models have the same type of battery. And the majority of electric vehicles being manufactured aren't designed necessarily to accommodate battery swapping. That being said, China has seen some success with this technology, especially with the EV manufacturer NIO. And as of May 2020, it looks like there were about 131 battery swapping stations in China. So we may see more of this in the future. Next are solar chargers. This technology can be paired with a level 2 or DC fast charger and is a way to provide off-grid or semi-portable power. It's possible to move the solar panels to a different location. It is a way to provide cleaner energy than what might be currently available on the grid. And another benefit is that it can provide charging in rural areas that may not be easily connected to the grid. The downside is that these solar chargers need to be paired with a battery system, which causes the price to increase substantially. The size of the battery could limit the number of vehicles that could charge there in a day. Paired with the fact that the sun might not always be shining, just makes this a really expensive option for a charger that may not be 100% reliable, depending on how many vehicles need to use it or when they would like to charge. Moving to the bottom row, overhead chargers are a way to charge generally electric buses via an overhead arm that automatically lowers and connects to the vehicle's roof when it is parked underneath it. They have very high power levels ranging from 150 kilowatts or higher, which can provide a very fast and powerful charge to the buses. Overhead chargers can occur en route, such as at a bus stop, or also at an indoor bus depot. The downside is that it's very expensive and not all models of electric buses are designed to accept this kind of charging. Lastly, overhead wires are a well-established way to power electric buses or trolleys, generally in urban areas. They can include 1 or 2 overhead wires, depending on the design of the system, and include a pantograph or trolley pole to connect to the wires. This technology has fairly limited applications for public transit and are seem to be used less common than they have in the past. Traditionally and most commonly, electric vehicle chargers are connected to the electrical grid and existing power production sources. The grid provides for a more consistent power that can charge multiple vehicles in a day, and where the grid already exists, connecting to a charger is much more affordable than establishing an off-grid power and storage option. Another benefit of grid-connected chargers is that they can serve an important role for electric utilities when it comes to balancing power demands. If electric vehicles are charged during periods of normally low electrical demand, it can help smooth demand peaks on the power system. There's also the option to connect chargers to off-grid power. Though there are limited examples of this being deployed, it is becoming more common. Traditionally, we see it with solar power as pictured and as discussed on the previous slide. As mentioned, this could be very expensive, especially when considering the cost of battery storage, but it could be a good option in rural areas with no electrical grid infrastructure. Widespread electric vehicle adoption is very dependent on well-planned and well-supported deployment. Here are 3 technology considerations that will make stations more accessible and easier to use for the public. The first consideration is network charging stations, which are also sometimes called smart chargers. These are connected to the internet and can send data to the site host. Data might include information on frequency of use or if the station is in need of repair. Network charging infrastructure also allows for payment options like radio frequency identification, smartphone, or credit card payments, the monitoring and analysis of usage data, and the ability to provide customer support. To install a network station, the site must have access to a wired or wireless internet connection or cellular service. These stations are in contrast to non-network charging stations, which are not connected to the internet and only provide basic charging capabilities without advanced utilization monitoring or payments. Another consideration is the creation of an all-inclusive charging location database or map. Electric vehicle owners need to know where stations are located, especially when planning a trip to a new city. Oftentimes, network service providers that own multiple stations may create their own map online or using a mobile app. But if there are multiple network service providers in an area or stations that are not associated with the provider, there may be confusion due to multiple maps or stations not being included on the maps. For this reason, it is really important for there to exist a single map that can include all public charging stations. This map might be created and maintained by the government, the utility, or a private organization. As an example, here at the National Renewable Energy Laboratory, we maintain a map of publicly available alternative fueling infrastructure in the US on the Alternative Fueling Station Locator. Lastly, mobile apps geared directly at electric vehicle drivers can serve many purposes. These apps allow EV drivers to access information on the go, such as locating stations or making payments, or even knowing if a particular station is currently in use or not by another driver. Mobile apps are often created by charging network providers or third-party developers. In section 2 of this presentation, I'd like to discuss different charging locations. This will include different considerations when locating chargers, home charging, public charging, and lastly, fleet charging. As electric vehicle charging stations can be expensive to install, it is beneficial to study and plan where best to locate these stations so that the investment in this infrastructure will both be utilized by electric vehicle drivers, but also encourage further electric vehicle adoption. Oftentimes, chargers are commonly installed in urban areas where many electric vehicle owners tend to live. Urban areas generally need a higher density of chargers to accommodate the larger population of electric vehicles. Additionally, electric vehicle owners will be less likely to have access to a personal or private charger that some single-family homes may have, so there will need to be more chargers in urban areas to accommodate the number of drivers who exclusively charge using public stations. An important consideration with the current generation of electric vehicles is they generally have a shorter range than comparable gas vehicles, meaning they may need to refuel more frequently in order to travel the same distance. This has led many consumers to have concerns about electric vehicles limiting their ability for long-distance travel. For this reason, it is extra critical for chargers to be installed at popular destinations, such as nearby towns, beaches, or other attractions, along with key highway corridors or commonly traveled routes between destinations. When locating charging stations along corridors, keep in mind the average range of electric vehicles in order to locate them along measured intervals so that drivers will not have to worry about running out of fuel. Addressing this range anxiety through the installation of adequate public charging infrastructure is a broadly recognized requirement to support the transition to electric transportation. Effective mitigation of range anxiety will require both widespread deployment of charging stations, so drivers can be confident in their ability to access a charging station, and vehicle models with longer driving range. While there is a lot of focus on deploying public charging, I want to acknowledge that electric vehicle owners are currently most likely to charge at home if possible. Research shows that at-home charging is currently the most common form of charging for personal vehicles. Since electric vehicles are likely to be parked at home for many hours during the night while we're sleeping, it makes sense that this is also a good time to plug in the vehicle to an outlet and slowly charge the vehicle overnight. Nearly all electric vehicle models can be fully charged with the level 2 charger in 8 hours or less, which works for at-home charging. And depending on the electric vehicle owner's driving habits, certain owners may rarely have the need to fuel outside their home beyond this. While charging at home is very convenient for many electric vehicle owners, especially in urban areas, many might not have access to a private charger or outlet. This is why it's critical that multifamily housing, like apartments and condominiums with parking areas, also have charging stations for their residents. This is something that policymakers can encourage with the use of specific building codes that require chargers to be installed in parking lots. For electric vehicle owners who do not have a dedicated parking spot with the ability to charge, they'll need to entirely rely on publicly available infrastructure, which we'll talk about more in the next slide. Before moving on, I did want to address the diagram on the right side of this slide. This pyramid shows the different electric vehicle charging infrastructure categories ranked by their likely importance for increasing electric vehicle adoption. Each of these rows are closely associated with the amount of time that a vehicle is parked in a given location, since that is a great time to be charging a vehicle when it's parked. Starting at the bottom, the first category or row we have is home charging, followed by workplace charging, which would include things like office buildings or other workplaces. This is followed by intracity level 2 and DC fast charging, and lastly, interstate DC chargers, which is needed for drivers to refuel on longer travel, such as multi-day or longer than a normal battery range would last. Public charging is especially critical to electric vehicle adoption since it is the most similar to how we currently fuel vehicles with public gas stations. They are also the most visible. As mentioned earlier, some drivers may be entirely reliant on public chargers to fuel their vehicles. When considering locations for public charging, you might compare and contrast it to how gas stations are currently used. With gas vehicles, you generally go to a gas station just to refuel and for no other reason. But because electric vehicles take more time to refuel, the approach is different. For example, with level 2 charging, it's best to locate them in places where people are often parked for an hour or more. With DC fast charging, it's best to reserve that more expensive investment for locations where drivers spend less time and need to quickly return to their travels. To demonstrate the location differences for level 2 versus DC fast charging, I've included the diagram pictured here. On the left side of the diagram, you'll see places where cars are parked for long periods of time. As mentioned earlier, the majority of charging generally happens at home during the night while folks are sleeping. Publicly available chargers located near apartments or areas of dense housing would work well here, followed closely by workplaces such as offices. In the middle, we have other places that cars tend to be parked for 1 to 4 hours or longer. With a level 2 charger, this amount of time could be enough to fully charge a partially depleted battery or partially charge a fully depleted battery. That kind of charge could hopefully help the driver get back home or enough to kind of top off their vehicle until they are parked somewhere else and can charge again. These types of locations are often prime examples of where electric vehicle drivers like to take advantage of opportunity charging. Opportunity charging is charging an electric vehicle while it is parked for another purpose, such as shopping or visiting an attraction. On the far right of the diagram, we have locations that are better suited for DC fast charging. Sometimes drivers really just need something that is most similar to gas refueling, and DC fast charging is great for this, especially for long distance travel along corridors or when traveling between towns. Drivers prefer this kind of charging and are generally willing to pay a premium for the ability to refuel their vehicle in a shorter amount of time. While charging for personal vehicles is the main focus of many planners and policymakers, I wanted to briefly bring your attention to the unique needs of charging fleet vehicles that are part of a public or private fleet, such as delivery vehicles or transit buses. This is worth your consideration because globally, the battery electric bus market is the fastest growing form of electrified transportation happening. We are seeing more electrified public transit vehicles in dense cities because it is key to traffic congestion reduction and air quality improvements. In the case of transit fleets or other fleets, it is important to fully understand the duty cycle of the vehicles that will need charging. The duty cycle is a way to understand how much a vehicle is used in a day through the number of kilometers traveled, the number of hours in operation, and the frequency and length of non-operational time. Listed are 4 major considerations for fleet charging. The first is type of charger. As discussed, there's level 2 charging and DC fast charging, which are both popular options, and the amount of time the vehicle is parked and how far it needs to travel will likely dictate which option is best. But keep in mind that some heavy-duty vehicles may also be good candidates for overhead charging as well. Next is where to locate the chargers and what type of access they will have, either public or private. Many fleet vehicles are accustomed to charging their vehicles privately at their depot and may prefer to continue doing this. This offers advantages of having control over the availability of the charger. But, depending on the route that the vehicle runs, they may need to use public charging and should do research to make sure that public chargers are available in locations that the vehicles need to travel to. Some fleets may also be able to have partnerships with other fleets in order to share private depot charging. Lastly, certain fleets, especially transit vehicles, may require en-route chargers so that the vehicle can get a full or partial charge without having to return to the depot. This is an expensive option though, but many transit fleets are pursuing this as they progress towards fully electrifying their fleet. A last major factor worth considering when it comes to fleet charging is how many chargers to install. It can be tempting to want to install one charger per vehicle, but this can quickly become quite expensive, so careful analysis of fleet's average vehicle dwell time, the facility's electrical capacity, and staffing availability should be reviewed. I mentioned staffing because some fleets may need to have more people dedicated to the management of fueling and moving vehicles around than they're used to, especially when they plan on charging at night in order to make sure that all the charging stations are being fully utilized at capacity and that the vehicles are fueled appropriately. This contrasts to fueling at a gasoline station when perhaps the drivers might be accustomed to doing that for their own vehicle. As a word of encouragement about fleet charging, I've included some pictures here of fleets that have made progress towards electrification. The first at the top is a military application, and on the bottom is a photo of a bus depot in Shenzhen, China, with many electric buses parked there in the lot. Shenzhen has added approximately, I think, 17,000 electric buses or so, and to fuel those, they've added over 500 bus chargers around the city, along with 8,000 streetlight chargers, and a combination of private depot charging as well. So it's generally, multiple types of chargers are needed for fleets in order to fuel in a way that works with their operations. In the last section of this presentation, I'd like to discuss the deployment of electric vehicle chargers. And I'll address a couple of things, including cost variables, a timeline of anticipated expenses, who owns and who manages charging stations, different business models, and how best to coordinate with the electric utility. On this slide, I wanted to touch on some of the cost variables that can affect the overall price of installing an electric vehicle charging station. First, equipment costs can vary based on many factors, such as application, location, charging level, and type of charger. When choosing charging infrastructure equipment, consider available features such as networking capabilities, the output power rating in kilowatts, number and type of connectors, and the number of vehicles that can simultaneously charge. Even the structure of the charger, for example, a wall-mounted unit or pedestal unit, can affect the overall price of the station. Generally, wall-mounted units are more affordable, about 30% so, than upright podium or pedestal chargers. Installation costs can vary based on many factors as well, such as the number and type of charging stations. For installation, don't forget to include the price of labor, which can vary significantly by region, along with permitting and inspection fees. Site work is heavily affected by the geographic location, site location, any required trenching, existing wiring, and required electrical upgrades that are needed to accommodate the existing and future needs of charging infrastructure on the site. Site work may also include signage and pavement markers that may be necessary to help inform drivers. Other considerations, such as lighting and minimizing vandalism, may be necessary and to be used as preventative strategies. Equipment such as motion detectors or anti-vandalism hardware may be necessary. When it comes to operations, the cost of operating a charging station includes, of course, the electricity, but also maintenance, as well as any monthly or annual internet access and networking fees. The cost of electricity to charge vehicles includes per kilowatt hour charges, as well as any demand charges incurred if the use of charging infrastructure increases peak demand and if the local utility has demand charges in place. DC fast charging equipment is more likely to trigger demand charges than level 2 charging. Note that some utilities may offer time of use rates or other rate incentives for charging infrastructure owners. General maintenance for charging infrastructure includes storing charging cables securely, checking parts periodically, and keeping the equipment clean. Chargers may need intermittent repairs. Warranty prices vary by manufacturer, including plans that are fixed term, renewable, and may or may not be included with the equipment costs. While ongoing charging infrastructure maintenance can be minimal, repairing broken chargers could be costly if they're no longer under warranty. Therefore, it's important to establish responsibility for maintenance costs and determine if the site host, charging network, or installer is responsible. Well, on the last slide, we discussed the multiple different kinds of cost variables. On this slide, I want to address the timeline that these costs or expenses can occur. The amount of time it takes to install a charging station is dependent on the project, but generally varies from a few months to over a year. Projects can take longer when the electric utility needs to be involved. Adding additional transformers, a meter, conductors, or even substations to a site can increase the timeline of the project. You can anticipate more involvement from the utility with DC fast charging stations or locations with multiple level 2 stations being installed due to the increased power demand on the site. When planning for a charging station, it's important to work with an electrician and to contact the utility as early as possible. Depending on the project, it might be beneficial to conduct a site analysis or feasibility study to compare the current power demands to the anticipated power demands on the site once the chargers are installed. Depending on the costs or infrastructure needed, it may be determined that another location or site might work better. We'll talk more about coordinating with your electric utility in a later slide. After conducting the site assessment, and once you've determined the necessary site work that will need to happen, you might then proceed to more of the administrative expenses of the project. That being said, depending on the project, these first two steps might happen concurrently. Administrative expenses, including financing, land acquisition, and permitting. Not all charging stations need to be owned and operated by the same entity that owns the land where it sits, but if this is the case, you'll need to work with the landowner on a leasing contract or shared ownership of the site. From there, you move on to the actual construction and installation of the station. This involves purchasing the equipment, installing the service panel and separate circuit breakers, along with any site work such as trenching and repaving. This area also includes the skilled labor cost to hire qualified and licensed electricians who are familiar with the codes and standards of installing charging stations in a manner that is safe for people, vehicles, and the grid. This phase could be delayed if you're waiting on the utility to install transformers or add additional power supply to the specific site. Oftentimes we find that a project is really beholden to the timeline of the electric utility, which is why we encourage you to get on their schedule and contact them as soon as possible. Lastly, once installed and operational, you might think you're finished, but don't forget about those ongoing expenses due to operations and maintenance of the site. On this slide and the next slide, I want to discuss some of the different business models that exist for public charging stations. Where there is a business, there are various entities that can be involved, so I'll review some of the more common options. Before getting into that, it's important to note that the business of owning charging stations is essentially the business of reselling electricity. This fact can potentially be a cause for concern in places where there are regulations limiting who can sell and distribute electricity. These regulations were originally intended to protect electric utilities, but the regulations have recently encountered problems with the proliferation of electric vehicles and charging stations. Without further clarification on these regulations, charging stations could be in violation. In this case, it will be necessary to have the utility commission, or even the state make a formal ruling on this issue so that owners of stations are not defined as a utility and do not encounter restrictions to reselling electricity through the operation of the charging station. So continuing on to the list of 5 of the more important entities that often own and operate charging stations. The first being the government. In some situations, it might be appropriate for the government to deploy, own, and operate charging stations. This is especially the case for locations that might not be profitable in the long term, but otherwise would still benefit from having a charger. This could be the case for rural communities, small towns, certain highways or roads that are less frequently traveled. Over time, if needed, the ownership could be handed over to a private business. Next being the electric utility. It's also appropriate for the electric utility to install, own, and operate public charging. This can be a really natural fit for a utility as they are already selling electricity and of course have control of the infrastructure necessary to supply power to the stations. Next is the most common option that we see, private charging network providers. And like I said, this is the most common one. Examples include auto manufacturers like Tesla, Toyota, or BMW, along with standalone charging companies such as Blink, EVgo, or ChargePoint. We are also seeing oil companies getting into the business and starting to deploy stations. An example of this is Shell Recharge at Shell gas stations in Singapore. Next, we have site hosts. A site host is the owner of a property where a charger is installed. Sometimes a charger could be part of a larger network, but not necessarily. This is often the case with workplace charging, where an office building might install a charger as a benefit for the employees who work there, but the station might be available to the public on the weekends or in the evenings after work, in which case it's just owned and managed by the office building or office park and not associated with a larger charging network. Lastly, we have another very common kind of situation that we see, which is a partnership. So partnership between 2 or more of the previously stated options generally. There are a lot of examples of this, especially when considering the many governments providing financial incentives to companies to install charging stations. One example is the state-owned utility in Thailand has partnered with 2 private companies, Greenlots and BMW, to install multiple level 2 chargers in Thailand. On this slide, I want to discuss business models in a bit more detail, especially as it relates to who installs, owns, and operates different components of the infrastructure. As you can see by this diagram, the electric utility generally always manages the distribution network, the transformers, and the meters. However, when it comes to the electrical panel and charging station equipment, we see a lot more variation. While there are only 4 business models listed on this diagram, know that there are in fact many different combinations for who can install, own, and operate this equipment. Especially important to note is that many of these business models can exist at once in a country, and this might in fact be necessary in order to provide full geographic coverage. I'll touch on each of these options in a bit more detail, but know that these are not the only options that exist. The first one listed is the quote, business as usual model. This model is the most hands-off for the utilities and the government, and it's the most private sector heavy of the ones listed here. In this case, the utility would install, own, and manage all of the utility system, and the private sector site host installs, owns, and manages the electrical panel and EVSE unit. This model makes sense where there is a strong likelihood of profit to be made from the charging stations. In this case, a private sector or site host is willing to invest a significant amount of capital up front without any assistance from the utility or the government. The next option is the make-ready business model. In this case, the utility is still a dominant player, but there's a growing role for the private sector or site host. Here, the utility would install, own, and manage all the utility system, and the private sector would install, own, and manage the EVSE. What is special in this case is that the panel and any associated conduit will be paid for and installed by the utility, but owned and managed by the private sector or site host. This model makes sense where the private sector is motivated to open a charging station business, but just needs a little bit of help with affording some of the initial startup costs. Next, we have the owner-operator model. In this case, the utility would install, own, and manage all the utility system and charging station infrastructure. And in this case, the private sector doesn't play any role in this particular business model. This model works best where government may want to strengthen their utility's financial position. It also makes sense in locations or market segments where the private sector is unlikely to participate, such as rural areas or infrequently traveled highway corridors. Lastly, we have the government incentive or electric company incentive business model. In this case, the utility would install, own, and manage all of the utility system, and the private sector or site host would install, own, and manage the electrical panel and charging station unit. However, the government would provide some sort of incentive to the private sector to help them do this. Government incentives can include many things. Examples include direct payments, such as grants, low interest loans, assistance with electrical design, permitting, and construction. This model makes sense where the private sector is motivated to open a business, but needs help with affording the startup costs. When the government or utility provides incentive, it can help smaller new businesses break into this industry. On this last slide, I wanted to talk about how important it is to coordinate with your electric utility. When we talk about deploying electric vehicle charging stations, we often spend a lot of time talking about the equipment and hardware needed for charging station deployment, but we can forget about the product, which is, essentially electricity. Now, utilities are generally excited to sell more of their product, and electric vehicles are a growing new market that utilities can tap into. That being said, mass adoption of electric vehicles could be difficult for current infrastructure to handle. So it's important to never assume that your building, parking lot, or even city can handle this additional load or demand. For large-scale deployment, always be sure to let the utility know about your plans. Some things to consider and share with your utility are the following. Specifically, where your charger is going to be located. Is it one level 2 charger at a local library, or is it 30 DC fast chargers along a highway corridor? This variation could, make a big difference in how the utility approaches the project and what kind of infrastructure development they might have to provide. Next, how much is the anticipated demand that the charger will have? It's important to do kind of analysis on this. Will the charger only be used, once or 3 times a month, or is it a charger that'll be used, 4 times a day, every day? If the latter, your utility might need to, create additional infrastructure to supply the power to that site. Next, it's, going off of that, you need to know how much power you need, what's the anticipated demand. Both you and the utility should understand how much new power supply the chargers need and if it's necessary to bring that grid capacity to these chargers. Knowing all this information will help you understand, first, if the project is possible, and second, what needs to be done to make it possible. This could require extending electrical distribution, installing a new transformer, adding meters. All of these projects take lead times and could affect your installation timeline, which is something we discussed earlier. Lastly, utilities play just an incredibly important role in supporting the projected future growth of charging infrastructure and managing the potential strain that charging stations can have on the electrical grid. Utilities can mitigate grid impacts by offering managed charging, also called smart charging, which can allow utility to remotely control electric vehicle charging by increasing, decreasing, or even turning off charging to help meet the needs of the grid. Lastly, utilities might even be able to offer incentives or unique ownership models for charging equipment and installation. This concludes the presentation for Module 2, Unit 2 of the Virtual Electric Vehicle Deployment for Southeast Asia course. Thank you so much for listening.